Hi guys, welcome to my channel. So today we'll be discussing about the problems related to the resistors which are connected in parallel. So in our previous video we have just discussed about the problems which are related to the resistors connected in series, but in today's video we'll be discussing about the resistors connected in parallel. Okay, so we all know the circuit diagram, right? How does it looks for parallel parallelly arranged resistors? So right, so this is how the general resist the arrangement of the circuit looks, correct? And you'll be having a battery generally. So this is how it will be arranged, correct? Now imagine, let's give the value for every resistor and the battery. Now if the battery is 12 volt, okay, and R1, I'll just name this as R1, R2, R3. Now suppose R1 is 5 ohms and R2 is 10 ohms and R3 is 30 ohms. Now if the question goes like this, suppose in the circuit diagram R1, R2, R3, which are 5, 10 and 30 ohms respectively, which is connected to the 12 volt battery and the current I passes through it. Now what you need to calculate in this, or what you need to find out, is current through each resistor. So current through each resistor, first thing, and the total current, and third is the total resistance. So what you need to find out, first current through each resistor, and then total current, and then total resistance in circuit. So this is what you need to find out. Okay, now we just saw the circuit. Now first thing, what was our first point? We need to find out current through each resistors. Right, now let us take R1, which is 5 ohms. Now according to Ohm's law, V is equals to IR. Since in parallel connection we know V is constant, correct? V is constant, so this remains as 12 volts, and I1 is unknown, and R1, since we don't know what is I1, I'll just write it as I1, and we know R1, which is nothing but 5, and this is 12. So what is I1, which is nothing but 12 by 5, which should give 2.4 amps. So this is our I1, that is current through the resistance R1. Okay, and now the current through the resistance R2, which was 10 ohms. Now V is equals to I R1, sorry, this is R2. Since V is constant, 12, I2, and R2 is 10, which should give I2 is 1.2 amps. Easy. Look how easily it is just going on. Like you just need to know the basics, guys. That's it. Right. And now let's calculate R3, which was 30 ohms. V is equals to IR. This is R3 and this is I3. So I3 is nothing but 12 by 30. I think 12 by 30, which should gives us around 0.4 amps. So this was our first part of the question. find the current through each and every resistor. Easy. So current through the resistance R1 is 2.4, current through the resistance R2 is 1.2 amps, and current through the resistor third, which is zero point 0.4 amps. Now let's move on to the second part of the question. Now the second part of the question said, what is total current? Now since you saw the circuit, which was something roughly like this, right? So this was like this, right? And this is how the circuit goes. Here it was I, here it is I. So this is nothing but I total or I current in the circuit. So which is, if you see here, it is splitting up into I1, I2, I3 through resistance R1, R2, R3. Got it? Look how it is splitting up. So if I want the total current, what I need to do? I need to just sum up all the currents. So I total is nothing but I1 plus I2 plus I3. I think which should come around 2.4 plus 1.2 plus zero point 0.4, which is 4 amps. So this is what the total current through the circuit. Easy. This is how easily it goes. Trust me, it is very easy. And now next part of the question. What is the total resistance, right? Now what is total resistance of the circuit, which is nothing but in parallel connection, it is 1 by R1 plus 1 by R2 plus 1 by R3. If it is 2 resistor, it is 1 by R1 plus 1 by R2. Since we have 3 resistors, it is 1 by R1 plus 1 by R2 plus 1 by R3. Easy. Now apply the values 1 by 5 by 1 by 10 plus 1 by 30, and this is nothing but 1 by RT. So 1 by 5 plus 1 by 10 plus 1 by 30. So the greater LCM is 30. 6 plus 3 plus 1. I think you know the LCM, right? So 1 by RT. So 1 by RT is nothing but 6 plus 10 by 3, which is 30, which is nothing but 1 by 3. So therefore the total resistance is 3 ohm. It's just a vice versa, right? 1 by RT is equals to 1 by 3. So that means RT should be equals to 3 ohms. Easy, guys. So this is some of the example regarding to the problems related to parallel connection. So in my next video, we'll be discussing of the combination of both parallel and series part. Okay. So make sure till then you practice the sums and never miss my videos, because it is just a continuity of each and every topic. So if you miss the video, never mind. Please make sure you're going back and watching the video. Okay. So hope I made the problem very simple for you. Okay. So we'll be meeting up in our next video, which is the combination of both parallel and series. Okay. So till then, make sure you like my channel and you like the video. If you're a new viewer, please do subscribe to my channel. Okay. Thank you so much. Have a great time.